Here are 4 high-yield USMLE-style questions focused on polymerase chain reaction, its steps, and clinical applications. Question 1. A 32-year-old woman with a history of neonatal HIV exposure undergoes PCR testing for the diagnosis of HIV. Which of the following steps in the PCR process involves the separation of double-stranded DNA into single strands? A. Annealing. B. Denaturation. C. Elongation. D. Amplification. E. Cooling. B. Denaturation. Denaturation is the first step in the PCR process, where the reaction mixture is heated to separate the double-stranded DNA into single-stranded DNA. This step is crucial to allow the primers to bind to their complementary sequences on the single-stranded DNA during the subsequent annealing phase. Question 2. In a PCR experiment, a heat-stable DNA polymerase is used to synthesize a new strand of DNA. Which of the following is the most likely polymerase used in this reaction? A. Taq polymerase. B. RNA polymerase. C. Reverse transcriptase. D. DNA polymerase. E. DNA polymerase 3. Answer: A. Taq polymerase. Explanation: Taq polymerase is a heat-stable DNA polymerase that is widely used in PCR reactions. It is derived from the thermophilic bacterium Thermus aquaticus, which allows it to withstand the high temperatures used during the denaturation step of PCR. This polymerase is responsible for adding DNPPs to the growing DNA strand. Question 3. A researcher is performing PCR to amplify a specific gene. The annealing temperature in the reaction is set to 55 degrees Celsius. If the annealing temperature is too high, which of the following is the most likely consequence? A. DNA strands will not separate properly. B. Primers will not bind to the DNA template efficiently. C. The DNA polymerase will become denatured. D. The primers will bind to nonspecific sites on the DNA. E. DNA replication will proceed too quickly. Answer: Primers will not bind to the DNA template efficiently. Explanation: The annealing step in PCR requires a specific temperature range for the primers to bind to the single-stranded DNA template. If the temperature is set too high, the primers will not bind efficiently, leading to reduced amplification of the target DNA. The annealing temperature should be optimized based on the primer sequences to ensure proper binding. Question 4. A PCR-based test is used to diagnose herpes simplex virus, HSV encephalitis in a patient. Which of the following PCR steps involves the synthesis of a new DNA strand after the primers have bound to their complementary sequences? A. Denaturation. B. Annealing. C. Elongation. D. Amplification. E. Cooling. Answer: C. Elongation. Explanation is the step in PCR where the DNA polymerase adds DNTPs to the 3' end of the primer, synthesizing a new strand of DNA complementary to the original DNA template. This step occurs after the primers have bound to the DNA in the annealing phase, and the temperature is increased to allow the polymerase to extend the primers and replicate the target sequence.